you said, what is that Java? Java basically is a high-level platform. Java is a high-level platform independent programming language, which was on principle of object orientation. Okay, so basically it's a high-level language, is a platform independent programming language, which works on principle of objects. So we're going to talk about three things today. Number one is high-level, two, platform independent, and three, is going to be object orientation. Can someone tell me what is high level? What do you understand by high level?
High level language is like English language, like human readable language.
Yes, human readable language. Anyone else? Everyone, when I say high level, what do I mean by high level?
I think it's a language that can easily be understood by a layman.
Correct. Yes, like you said, high level is human readable language. So that's what Java is. Okay. So if I show you this right now, high level means English-like language, which you can understand. For example, let me say, if we talk about the hierarchy of computer language, if we talk about the hierarchy of computer language, if I to show you this, if you talk about the hierarchy of computer language, we can see that like right now, almost every computer language is a high-level language. But before that, initially, before the programming language came into existence, came into the concept, in the first phase, hardware level language was created, means whatever language we were using was for a particular machine, right? For a particular hardware. Then the next came the assembly language. After assembly language, then came in the high level language. Look at this diagram very, very carefully. It's an hierarchy. So what happened was that when we are using machine language, all the code that we use to write was written in the form of bits, in the form of 0. Everything you are writing was in the form of bits, in the form of 0 and 1. Okay? Bits. Like in your engineering, I don't know if you have heard about bit electronic concepts. Abraham, have you heard anything about that? In engineering, bit electronic concepts.
Yes, I heard about that.
Okay, you can know that in your bit electronics concept, you must have heard or learned that anything the processor does, it is a form of bits. That is in the form of 0 and 1. I'm talking about this machine language. It came about machine languages. Okay, so the machine language makes it tough and complex. All right, the machine language makes it tough and complex. In machine language, same as 0, you can see something like 0, 0, 0, 0, 0, 1, 1, 1, 1. So it's kind of being complex. in 0001111010101 complex. So this format, to write anything, it was very complex to learn and complex to implement. The main drawback of those machine language was that those programs was machine dependent, right? It was machine dependent. Means when we're writing any programming using machine language, that program will only be executed on that machine only. Then came what? Assembly language. We must have heard this in Java. I don't know if you have heard something like this. When I say int var equals to 10, then execute. Nikki, have you seen this before? I know you, brother. I don't understand if you should know this, but
Yes.
have anyone seen something like that before?
Yes.
Ever have you seen anything like that before?
Not
Int
really.
var equals to 10, semicolon.
Yes.
So what does this mean, Nikki?
It means integer value, and like when you're writing Java, it's always like your, what is it called? The integer value, which is that 10, has to be end by a semicolon. That's when you're what I can explain is that the int is like a data name, and the value is 10, and the variable, which is I don't know if I'm
Yes, okay, you have some kind of idea. Okay.
yeah.
This means we are storing a value 10, this value 10. Okay. In Java, execution starts from the right. Okay. It's right, left, right, left. So execution starts from here. So you're going to understand that later. I don't to go into more detail about that. This means we are storing this value, okay, 10 into a variable. This is a variable, just like a bucket. All right. We are storing this value 10 into this var, whose data type is. So you know that this one is integer, is something to do with numbers, right?
Yes.
10.
Yes.
So it should contain this data type. So this means we are storing a value 10 into a variable var whose data type is what? Int. So at least we can understand what was written over here, right? You can understand this. We used to do the same in assembly language. In assembly language, back in the days when assembly language was in the market, we used to write something like move hash 23, comma, D4. Okay, move hash 23, comma, D4, where D4 is a location, kind of register. Okay, D4 is just a register, a location kind of variable, where we are storing this 23 as a value. We are storing this 23 as a value, and sorry, as a value, move. This move is a command to store a value into this location. So we used to do that in assembly language. So this is what we used to do in assembly language. Now, when assembly language came into existence, it makes the life of a programmer a bit easier as compared to the machine language. But still, the life of the programmer was very complex because writing int var equals to 10 semicolon was much easier compared to the assembly language. This is more easier compared to the assembly language. We have to, in assembly language, we have to use some kind of mnemonics. Everybody understand what I mean by mnemonics? To learn some commands for that particular thing. I've heard about mnemonics.
Not. Maybe I've read it before, I have not.
Yeah. So in that assembly, we have to use some kind of mnemonics to learn some command for a particular thing. That when it comes to assembly language. But when high-level language came into existence, came into the market, when high-level language came into the market, everything became very, very easy. Like same thing, like we are writing move as 23 comma D4 can be written as int var equals to 10. We are storing this value into this variable var, which data type is integer, because integer are due to numbers. So high-level language means everything you are writing in the programming, anything you are writing in the program will be writing using simple language. What I mean by simple English language, that's what we mean by high-level language, which anybody can, you and I can read. And almost every language in the market these days, all are all high-level language, be it Java, C#, C++, Ruby, Scala, all are all Python, all are all high-level languages. Clear, anyone? Question? So high-level language means English-like language, simple English-like language. That was said, Java is what? A high-level language, okay, which can work in principle of what? Or object orientation. But these are things we have to talk about. Now we have covered what is high level. Now, platform independence. Why do we say Java is platform independent? I hope you are clear what I mean by high level. If you ask your interview what is high level, why Java is high level language?
Yes.
Okay. Are you clear with that? Any question? Satroma, are you clear with what you mean by high level?
Yeah.
Okay, that's what is just an English-like language. It's all from the hierarchy of computer. Back in the days, we started with this. It moved up to this hierarchy. Anything you do in machine language, you have to be executing that machine language, only in bits. Okay. Then the life of a programmer was very, very difficult. Where everything you have to do have to be executing that particular hardware. Then came the assembly language. It makes the life of the programmer a little bit easier compared to this. Where you say move hash command D4, you are storing this value. So it makes it a little bit easier. Then comes the high-level language, which is English-like language. We can be able to understand this. So it makes the life of a programmer very, very easy. So high-level language is English-like language, what you can be able to read and understand. So that's what high-level is. Then coming to what is Java, you say Java is basically a high-level language which you just understand. It's an English-like language. Then platform independence. What do I mean by that platform independence? Java is platform independent.
Can I try? Okay.
Yes. Okay. So what I mean by that platform independence on Java is that can someone tell me the process of writing a code in Java? What are these processes of writing a code in Java? Java has 3 processes of writing a code in Java. What are those processes of writing a code in Java? Can anyone tell me the process of writing and running any code in Java? What we have to do first? Like, we
You
have
have
to write the
to,
code, okay? What are those three
um,
processes?
I will say you have to create maybe the object and the class or something,
Mm-hmm.
a method.
Yes, we'll come to that. Just the three processes of writing and running any code in Java. So let me help you. What we do
So,
have to do first, like we have to write the code, okay? Java, before I explain what we mean by platform independence. Now, there are three processes to write a code in Java. You write the code in high-level language, right? Which is English-like language. Now, okay, there's three processes. You have to write the code, you compile the code, then you run it. Three things. Now, let me show you this. Now, this is my um this is my code, okay? If you don't understand it, don't panic, you get to understand this later. For example, I'm writing a Java file, okay? So the process of writing and running a code in Java, first you have to write the code in a file, and then you have to compile the code to check the syntax of the code you have written, and you have to execute that code. Those are three processes. One, you write. Two, you compile. Three, you run. Finish. Okay. Now, look at this. When I'm writing a code in Java, when I said public class text, open curly braces, open closing curly braces. If you don't understand, don't worry about it. You got to understand this later. You start writing your code. Don't worry. So now I write this code in what? In a file called this, when I want to save this file, if I want to save it, you can see this. It's in text file, right? It's a text file. This file is a text file. But in Java, whatever code you write should be in .java file. Like this is going to be in .java, not text. Okay? It's going to be this is going to be in .java file, an extension of .java. Okay? Just for instance. Okay, that's what I'm just trying to show to you. If I had to compile this code, this one is this is a text file, all right? If I have to save this, it say this is a text file. So, but in Java, when you write a code, whatever code you write should be in .java file, not in text file. All right. .java file is nothing but an extension. Like this one is an extension, right? Because this is a notepad. A notepad is the extension of this is text. .text.txt, text file. Like we have in Java. In Java, we have anything you write in Java, the extension will be the .java. Okay. Like in text, in Notepad, anything you write now want to save, got to be in TST. In JSON, in CSV file, if you're writing anything you want to save in CSV file, you have to be .csv, CXV. In JSON, a language tool, anything you're writing in JSON formats, for those that do API testing, you see that word. Anything I want to save on, it have to be in JSON format, .json. In XML, for those and you have idea of API, I'll talk to you about API testing, so something about talk about XML file, right? Anything you want to save on that file has to be in another extension of XML. Now, someone tell me in Python, what's going to be the extension? If you want to save any programming high-level language you want to save in Python, what's going to be the extension? What's going to be the extension?
.pynb.
Or what?
.pynb also.
Python.py.
Yeah.
So Python extension.
.py.
Or
Okay.
JavaScript. Anyone for JavaScript? JavaScript. .gx. JS extension, what you are saving. Another language called PHP is a high level language. If you want to save the file, it's going to be .php. So these are different file texts. Like in Python, we write extension .py, py. Example, for example, now I'm using Windows, okay? Windows 11. Now I want you to understand what I mean by what the platformity of Java. Why Java is what platform independent. We all understand what's high level language. Now, to understand the platformity of Java, that's what I'm trying to illustrate this into you. When you're going to save your file, even your Microsoft Word, you're going to save an extension. Okay, Word documents. If I want to save this file now, it's going to be on TX, text file. In Java, I need to go to write in Java. The extension is going to be .java, Python.py, JavaScript.js, PHP, JSON.json, CSV. All these are all what like we have. They are all extension of their own text files. Okay. So right now I'm using Windows 11. What we did is, or what I did is that to create a file in Java, if I used to create this one, if I have to save this one, it will be in what? It will be in text.java. That's the extension, or what I'm saving the file, and it's going to be the extension of that file. Okay. Don't worry about this. This is a text. This is the class text. Okay. Don't worry. You're going to understand. We'll start talking about text. So if I want to save this thing now, I want to save this file. Say this is my text. Okay. You have to be the extension of this particular thing I want to save. It's a Java file I want to save. So it will be text.java. If it's Python programming, it will be text.py to tell you that it's a Python file I'm saving. It's a JS, it will be this. If I want to save this one now, I want to use the name to save this. I said this is Notepad, save as. If I have to save this right now, I said, let me say, Java batch or Java class, or let me use platform, Java platform or whatever, or tutorial. If I have to save this file now, if I should save this file, if I save this file now, if I go to my You can see the extension here is this documents, okay, .text. That's the extension. I say this notepad. So that's just what I'm trying to illustrate to you, so understand anything you are trying to save, any code you write in Java, it will be the extension of that text you are saving. So right now I'm using, to further explain what platformity of Java is, right now I'm writing, I'm using Windows 11. What we did is to create a file called text.java, okay? This file contains some codes, like here, maybe I've written some kind of code, okay? So the extension is called text.java, all right? That's the extension. So I created this file on a system which contains Windows 11. So when I said operating system is, what I mean by operating system, or is equals to, operating system is equals to OS. If I said OS, which is operating system, operating system equals to platform. So when I said operating system, I mean platform, whatever platform you are using. So when I say OS, operating system, like I'm using Windows 11, okay, operating system. So that's the platform I'm using. So when I said OS, OS is equals to platform. That's the same thing I'm just trying to tell about. Okay, so now we create this file, this Java file, okay, this programming, we write our program, okay, in Windows 11. Then I compile this particular program. What I mean by compile is I saved it as a compilation. And I told you that Java has 3 steps of writing. I said you write the code, you compile the code, then you run it, right? So to further explain the platformity of Java, when I write this code, I write it in the .java file. And I've written this code in Windows 11, in any Windows 11. So we don't want to execute. I don't want to execute. I don't want to run it. That will mean I execute. I write it in Windows 11. I compile it in Windows 11, but I don't want to execute it. I don't want to run it on the same Windows. Okay, I want to execute this file on any Windows. Okay, which contains either Linux or Mac operating system. Remember, I said operating system equals to a platform, any platform. I want to execute this in a different platform. We have Mac, Linux, Windows. So this compilation I did was in Windows 11. I write it, compile it. When I compile it, then I want to run it, but I don't want to run it on this particular operating system, platform, Windows 11. I'm using Windows 11. I don't want to execute it here. I want to execute it in other operating system that is using, that contains Linux or Unix machine. Okay, remember, whenever I'm using the word operating system, that OS, I mean platform. I want to run it in another platform. So now, what is happening here? The platformity is getting changed, right? Like I created the file in Windows 11, compiled the file in Windows 11, but now I want to execute the file in another machine that contains different platform. When we say platform independent, it means that what?
It
Guys?
can run.
So when I say the platform independence means that we can create Java file in any, we can create Java file on any operating system or platform, and we can execute the same file any other operating system without doing any changes. We can write any code in any operating system and execute the code in any operating system without doing any changes. That's what we say, write one, run anywhere principle. That's why platform independence of Java. But I further explain to you why Java became more platform independent. When you start installing your Java, you understand more what Java is more why we say Java is what platform independent. So if we go to Google and then you say download, we have different Java source right now, up to Java 12 or so. So let's say this one is more stable too. I'm using Java 12, but let's say download Java 8. Okay. Come here, oracle.com. You can see download Java. See Java 8. You can see this is Java 8. But something I want to show you. Why is Java 8 recommended? Okay. There's one I want to show. Let me go back to the other one. I already have Java 8 on my system. I don't want to download it again. The one I want to show you. Let me go to oracle.com. Okay. You can see this. Okay. So you go to Google and say download Java 8. Java has up to Java 12 or so. Okay. So you can see when you go to Google, you say download Java 8. You can see we have different packages. I hope you can see my screen. You have different packages of Java. When you start downloading this Java, then you understand what I mean by Java is platform, the platformity of Java. You fully understand it. Okay. So when you go to Google and say download Java 8, you can see we have different packages. That is in Windows, we have 2 packages. You see? Which means although Java is platform independent, but for different operating systems, we have different Java packages. For Linux, we download Java compatible for Linux. For Mac OS, you see, Solaris, you have that. Windows, you have that. Which means although Java is platform independent, but for different operating systems, we have different Java packages. Because when you are going to download Java, you have to download the Java compatible with your own operating system. Which one are you using? How do I know which one am I using? When you go to here, when you go to your Windows, you go to your PC, you right click on your PC, you go to properties. You can see mine. I'm using 64 bits processor, operating system. You can see that. So which one am I going to download? 64. So you go and download here, download this one. Okay. So like currently I'm using Windows 11, so I'm going to download 64 bits. So you want to know which one you're using. If you are using Windows 32, I think you're going to download 84 bits. Yeah, 84-bit window. If your operating system is 32 bits, you download this one. So I have downloaded Windows 34, and there you have to right click and do some next. Very easy. You click next, and you can see here. If you can see when I download this, you can see some .exe files here. Okay, I want to go to this and download this. You can see some .exe file will be on your system for it to accept the license condition, and then you click on next, and exe file will be downloaded into your system, which I have to install as a normal software. And I repeat again, when you have check your own operating system, if you are using 32 bits, you download this one. So whenever you see 82 bits, that means you are using OS operating system 32-bit Windows. Then you click on next, and Java will be installed. Always know that Java will always be installed in your C drive. Okay? Java will be installed in your C drive. You can see, go to a program file. You can see Java here. Java will be installed in your C drive. When you go to your C drive, you go to your program, you go to your programs files. Okay, you see Java here. Then inside Java, you will see 2 files. Why you can't see these two files on mine is that I downloaded Java 12, Java 11. So if you are download Java 8, you're going to see two files. When you click here, you're going to see JDK and GRE. JDK and GRE. All right. That file, you're going to see JDK and GRE. Can someone tell you what is JDK? Now that's brought us to what the platformity of Java. When you start downloading Java, someone understand what we mean by that platformity of Java. Can someone tell me what is JDK and GRE?
JDK is Java Development Kit, and
Okay.
JRE is Java Runtime Environment.
Okay. JDK is Java Development Kit and GRE is Java Runtime Environment. Now, in Java, we have 3 steps we have to follow to execute any program. What was that 3 steps?
You write the code in a file.
You write the code.
You compile the code. You run the code.
You want the code. You want the program. So now, why are you learning this Java? Why are you learning this Java? You understand, being an automation engineer, your task will be to require is to do these three steps. You have to write the code, compile the code, and run it. So what is compilation is? What is compile? When I say compile, what is compile? What I say compile, you see Java has 3 steps. What is compile? When I say compile, you say we do what? We write the code, we compile the code, and we run it. So what is compilation does? What is compile?
I think to compile means to bring it together. So
Okay. So when we write the code, we write the code in a high level language, right?
yeah,
English style language, normal thing that a human can understand. Public class text, open curly braces. Don't worry, you understand this. This is the English language, public class of 2006 students, class of 1999, class of 2014, class of, class. You understand what we mean by class in Java, objects and all those stuff, but don't worry about that, okay? So these are English-like language, right? So when we write the code in a high-level language, English-like language, normal English, that human can understand. Now, compiling code is writing in .java. When I compile this code, it's going to be in .java. Which contains English, and the processor does not understand English. So compiling code is written in .java file, which contains English, and the processor does not understand English. Your processor, your CPU, doesn't understand English. Any operating system does not understand English. Either your Windows you are using, either your Linux, either your Mac operating system, any operating system you are using does not understand English language. You're writing this particular code. You wrote this code in high-level language, English language, but your PCU, CPU, operating system, no, not any understand English language. Because processor understand bits. And what is bits? Bit is the form of what?
0 and 1.
0 and 1. So we cannot execute the .java file. We can't execute this thing. You are just waiting there. We can't execute it. We cannot execute the .java file because the processor will not understand what you want to execute and provide to your output, your code. You don't understand what you want to execute and will not provide you your output to your code you are writing. But to make the programmer life easier, okay? But to make the programmer life easy, we are using the high-level language. But ultimately, when you are supposed to execute that code, you have to provide the processor the code that the processor can understand. And the processor only understands binary language. Binary language in form of 0 and 1 format. Let me first show you this slide. Let me show you this here. You can see this. I told you that Java basically working of Java is divided into three parts: write a code, compile the code, execute the code. All right. So now you wrote the code in high level language, the processor doesn't understand it. You understand only binary bits. Okay. So every programmer, every programming language has some grammar. Okay. Every programming has some grammar. And if your code is not written as per the grammar or syntax of that programming language, you will not be able to execute that particular code. You're writing your language, your program in high-level language. So when you write a program in high-level language, what will happen is that when you compile the code, listen to me very carefully. When you write a code in high-level language, when we compile the code written by Java, the .java file written by high-level language, when you write a code, you write a code in high-level language, which is .java file, right? So we compile the code using compiler. Compiler comes into the picture. Look at this diagram very well. You wrote a language in your Java file, which is English-like language. Then compiler comes into the picture. Compiler will then compile it, convert it into what? Byte code. Okay? You wrote a language, this in what? In Java. When you wrote a code in English language, remember, processor doesn't understand English language. Then when you compile the code, okay, compiler comes into the picture. Then compiler will convert this high-level language you have written. It compiled it to a what? To a machine, a byte code. This is a byte code. I hope you understand it. Any question? This is architecture, how Java works, how your system is operating. When we compile the code written by Java, the .java file written by high-level language, we compile the code using compiler. Compiler does two things. Let me tell you two things compiler does. Number one, it checks. Compiler comes here and check. Compiler does two things, right? Compiler does two things. One, it does what? Compiler will convert, it will check the syntax of the code you have written. Okay, so it will check the syntax of the code you have written. If the code is as per the grammar or syntax of Java. Because every language has a grammar. Chinese has a grammar. English has its own grammar. So when you compile the code, compiler comes to the when you compile the code, compiler comes to the picture and check if everything you have written is per the grammar of Java. Okay? It compiles it line by line. Okay? Like, for instance, if I should show you this, don't get panic, but just see, like this code that is written here. Let me see something like this. So as before you open it, but I said compiler does two things. When you write your code, compiler does two things. Okay, it will first come in and compile those codes using compiler. It checks the syntax or the code that the programmer has written. That's number one thing it does. It checks the code that the programmer has written if it's per the syntax. So of the grammar, if it's in line with what is, you see, like if you see this code that is written here, what compiler to, I have written this code. Now compiler comes to the picture, but you don't see this when you're writing Eclipse. It does at the back end. So if I have to run this code now, if I have to run this code on a Java application, if I have to run this code, it says it compiles and give you the output. Okay, you can see the output here, wait 122 automation. You see that? It is, so what does, just don't worry about this, but that's what compiler does. It checks the syntax, if this thing is as written as the grammar of Java, there's no error in this thing before it can give the output. So it compiles the code line by line. Like I said, line number 3, 4 is empty here, 5 is empty here. Everything, there is no, see, if I made a mistake here, I put X here. You see, there's error. You see that cannot be resolved to it. But don't understand, you understand this. I'm talking about string here. Okay, you remove the red line. So that's what compiler does. Compiler comes into the picture and check if the syntax of the code that you have written here, the syntax of those codes you have written here, if it's as per the grammar of Java. Every language has its own grammar. English has its own grammar. Chinese has its own grammar. So that's what compiler does. Two, compiler will do what? Compiler, it will check, it will convert the high-level language. The compiler will convert what? The high-level language into what? Two, what compiler does there? Converts high-level language to bytes code. Any question? Two things it does, compiler does for you. When you write your code in a high-level language, it compiles your code, compiler comes in the picture and converts it and to check the syntax is as per the grammar of Java, okay, which of the code that the programmer has written. Two, it will convert the high-level language, which is English language, to bytecode. But the processor does not do what? Understand bytecode. It understands machine code, which is in the form of 0 and 1. So when you execute this file, then you can see from this diagram, interpreter comes into the picture. The interpreter will first convert the bytecode to machine code, and then we give you what? The output. Abraham, I hope you understand this. Okay, you have any question? All this thing, I'm trying to dive into what platformity of Java is all about. We learned about Java is a high-level language. Now, the platformity of Java. When you go to download your Java, you're going to download two files, JDK and GRE. You see two files in Java packages. JDK, and GRE. Okay? So to further explain how Java works, before I dive into the platforming of Java, when you write a code, in high-level language, which is understood by a human. Then the processor, the CPU, does not understand English. It understands machine language. It understands 0 and 1. So compiler comes in the picture and compiles this code and converts it to what? Byte code. But the processor does not understand byte code. It understands machine code, which is the form of 0 and 1. So when we execute these files, the interpreter will first convert the byte code to machine code, and then we provide us the what? The output. That way you can see on your screen. It's just going to be a short class. I don't want to bother you much about this. So we're going to stop it for today. We continue next slide. If you have any question, I just want to make it brief.
So I have a question.
Yeah.
Yeah, I look at the example of the code you wrote, the way you wrote the strings and n equals to 1, n equals to 2, like that. I'm talking about this code. Why is it that there's always a space? Like you have line 1, line 2. What happens if you write on line 2?
Nothing happens.
Will it still run? Yes.
Nothing will still run, yeah.
It will still run.
Yeah.
Okay.
Let's see what happens.
Okay. Can we try and run it? Let me see.
To run again, there's no compilation error. Compiler compiles it.
Okay.
You can see the output. Space doesn't matter. It doesn't
matter. The space doesn't matter.
Yeah, it doesn't matter.
Okay. I wanted to know.
You got to know about that when you start doing your main mistake. This is few classes going to be theoretical. What I want you to understand the theory, how it works.
Okay.
You understand? I don't want to start jumping into a class in Java, objects in Java, this, that. No. What is the history? How it started? What is this Java? Understand the history. How it's being run? What am I seeing? How am I visualizing these things? What are bytecode, machine codes? Why is when you sometimes ask you is that can you explain why Java become platform independent? What is Java? Okay, can you explain the platformity of Java? So this is what I'm trying to explain to you. Okay, it's from the hierarchy of computers. See how it is. We used to have machine language. Everything you do, you execute in that machine language. It makes the life of a programmer very, very tedious. Okay, and anything with zeros and one. So then come the assembly language. As I just showed to you. From assembly language, then came the high-level language. Everything in the market today, they're all high-level languages. Be Java, Ruby, C#, Python, and all those. They're all high-level language. So they made the life of a programmer very, very easy. You can see back in the say all the Fortran, C#, all those things are all high-level languages. So since Java is platform dependent, platformity of Java is what I just trying to explain to you, but you're going to explain more and you got to get it when you start downloading your Java 8. You can see your packages of Java. You download the C and Java package. In that Java package, you get 2 files there. But I have these days Java 2.11 doesn't have those. I think they included, it's already that JDK, GRE. They included the GRE in JDK. You understand what JDK is. She said JDK is Java runtime environment. JDK is Java Development Kit, and the GRE is Java runtime environment. When you download Java 8, you won't have these 2 packages. Well, because I downloaded Java 11, I don't have it because in Java 11 version, they made it to be inside of that JDK. There's no point of having GRE inside because GRE is part of JDK. But I'm going to explain that to you in our next this thing, because this intro, I want to break it down so that you take it step by step. Okay, I just want to make it more easier so you understand Java very well. Start from the history. Mike, you have any question? I just want to make it brief.
No, this is actually my first time joining the class, so I'm still trying to, pick up what you're putting down. I appreciate you, though. I really appreciate it.
All right. So you can see how it works. This is a platform. This is how it works. Okay. When you write a code, you write a code in high level language, which is understood by human. So when you compile that code, compiler comes into the picture and convert that to English language and written, because your CPU, your operating system, your Windows or Mac doesn't understand English language. So the work of the compiler does two things. It comes and checks the syntax. If your code is according to the strict syntax rules of Java, then compiler compiles the code and converts it into bytecode, which is not understandable by human beings. Bytecode is not understandable by human beings. When we start doing the theoretical aspect of it, we start understanding what this is. Okay? It's not understandable by human. Only machine can understand it. After converting of your code into bytecode, the interpreter executes the bytecode line by line, interprets all these things, starts executing it. Because the compiler has already compiled it and it's at the strict syntax of Java. Every language has its grammar. Compiler will check all those things. That is at the strict syntax before execution starts happening. If there is an error here, look at, yes, you see, there's error. See, don't worry, you understand this when you start doing yours. You see that error exists in the project online, but this is a cannot execute to throw an error, give a exception error. That's what we're going to talk about when we do Java. Talk about exception handling in Java. How do you handle this exception? Exception in thread mail, Java line, this and that cannot be resolved to what to a type, string, this and that is fine in this. It will even tell you where the code line is fine in what in line 11. So what does that? Compiler. And give some fix to fix it. And fix it and can run. We start debugging, but I don't want to go into debugging. And we will start understanding that. I just want to understand the history of Java. Compiler does it. Compiles the code line by line. When you compile your codes, which is not understand by English language, compiler converts it to bytecode. And bytecode is not even understood by a human. Okay? So interpreter then comes into the picture and converts from bytecode to what? Machine code, and which is understood by the machine, and you see the desired output. That's what you can see on your screen. All right, guys, this lesson will be very short. We have never started, just a brief introduction. We have to go into more depth introduction and downloading your Java and why Java is platform independent. And we'll talk about variables and talk about difference between JVM and GRE, JDK, and Java source files and declaration of Java. And there's some strict rules you have to know in Java in naming identifiers. What are those identifiers, Java components, and you understand that. Okay, if I should take it right now, we spend like 3 hours. So I just want to get it in brief. Any question?
So Stanley, that implies that we are not going to talk about object orientation today.
You know, we'll talk about object orientation. We'll talk about it in next section, next class. I won't take it slow by slow so we understand it.
Okay, it's very good. It's very, very good. I love that. It's very good.
Yeah, I want we just understand what this Java. You still talk about source. I've not even come here. So all these are the topic for today. But if I take it today, I don't think we have to take for 15 minutes break and come back again. 15 minutes so you digest it and everything. So I don't want to take it so much. I just want to just give you a brief intro of this, what Java is. At least for you know what Java is. Java is a high-level language, which is an English language. Understanding by a human. It's a platform independent, which is stop here. But I still want to dive into when you start downloading Java, talk about JDK and GRE, either understanding what the platformity of Java is. Then object orientation is what we treat next. I've not finished with this. All right, platform independent. Okay, platformity of Java. That is, class file of Java can run in any operating system without doing any changes. Why? You got to know that in the next section.
Good. Thank you.
All right, we continue next time. All right, have a good day.
When is likely next time?
Maybe Friday. I'll let you know.
Okay, thank you so much. I appreciate it.
All right. Anybody have any question? Mike, you have any question?
I don't know whether it's a one question or something. When you were talking about the compiler converts the high level language to bit code. After compiling and it's only the machine that understands it, do they go back to the high level language again?
No, when you have already written the language, you have already written your code here. You are writing your code in English language.
Okay.
Like what you wrote, any language, there's just you wrote public class, you wrote your code. So your processor does not understand these things when you write it in your machine, your operating system. You write your computer, it doesn't understand. I want to run this code. Your processor, your CPU in your computer doesn't understand it. So when you compile this code now, you compile this .java code, this extension. When you compile your code, compiler comes into the picture. It compiles the code and converts it to byte code. Okay? Because the CPU doesn't understand the English language. So compiler will help you to convert it to a byte code. When you convert it to byte code, then the interpreter will then come into the picture and then convert it from byte code to machine code, because that's the only thing the processor can understand. So the beauty of it is that the main thing here is the interpreter. So the interpreter is the one that gives you the output, that helps you to convert the byte code, but the processor doesn't even understand byte code. You understand machine code, which is the form of binary 0 and 1. So interpreter will then come into the picture and convert it from from byte code to machine code, then gives you the desired output, what you can see on the screen. After converting of your code into byte code, interpreter executes the byte code line by line. The beauty of it is the interpreter. That's what happens at the back end. That's the architecture of this Java, how Java code works. 3 basic steps: write your code, compile the programming, and execute. But I'll further explain to you more when you understand how this thing works, when you talk about the GRE and JVM and GDK. Any question, guys? Okay, we end it today. Let's start tomorrow on this.
Hey, thank you so much, sir.
Thank you so much,
Yes.
science. Thank you.